I'm going to look at integration, and it's a set of North Lanarkshire notes that are used in school or in class. So listening to these might give you a wee help when you're doing it in class. Okay, basically integration, this whole section just means that integration is the opposite of differentiation. The symbol for it is that wee part there that looks like, and I'll draw it out again, that there. That's the symbol for integration there, it's there. And it's written down as, if you want to take the integral, it's the integral of, say, x to the power of n, and you say dx. Now, I use just a way to remember and to help pupils. Dx, do the x's. That's not actually what it means mathematically, but remember it as it's the integral of x to the power of n, whatever the function is, and you're doing the x's. So that's all you have to know from that wee part of your notes. Now, getting back to this thing here, it goes through a whole lot of stuff here. The only important bit here is this bottom part of your notes. Okay, so not too worried about all of this. Basically, if you want to find the integral of anything, if it's x to the power of n dx, you must have dx when you've got an integral because it's got to tell you to do the x's. The rule is that you increase the power by 1. Okay, so you increase the power by adding on 1, and then you divide by the new power. Okay, so if we follow that rule for that one up there, we've got increase the power, drop the integration sign because we're doing it, so that would become x to the power of n plus 1, divide by the new power, or dividing by n plus 1. Now, when you integrate, you've always got to put in a plus c. The plus c stands for the constant of integration, because you know that when you take the derivative of a number, it just disappears. So when you want to go back to find out what that number is, you can't because it's disappeared. So you put in plus c. So the only thing you need to remember from this page is the integral of anything. Take the x's, add 1 onto the power, divide by your new power. Don't forget to put in a plus c, your constant of integration. Right, once you've seen a few done, then it gets easy. There's your rule there again. We're going to increase by the power, so integration, I for increase. Okay, so we're going to increase the power and we're going to divide by the new power. Right, so we've got the integral of 2x. Now, 2x is really 2x to the power of 1, and dx means we're doing the x's. So we're going to add 1 onto the power. Leave that number sit there. That doesn't matter. That just gets written down. So increase the power becomes x to the power of 2, and we're going to divide by the new power. So we're dividing by 2, and we're putting in plus c. Now at this stage, you can cancel, and you can tidy up. Those 2's cancel. So basically my answer there becomes x squared plus c. This one here, we've got the integral of 4t squared dt. So I'm doing the t's. So forget everything else, leave that 4. And the t's, we're going to add 1 onto the power, and we're going to divide by the new power, and I can't forget, I must put in plus c. If I want to tidy that up, I can write it as 4 over 3 t to the power of 3 plus c. This one here, it works just the same as your differentiation. You can have more than one term in a string. So we've got 3x to the power of 5 minus 4, and we've got dx there, which means I'm doing the x's. So when I'm doing the x's, the only important bits are if we've got x's. Okay, so our rule is add on 1 to the power, divide by the new power. That 3 stays where it is, so I'll write it down. Increase the power, so that 5 becomes 6, and I'll divide by the new power, divide by 6. Then I've got a minus sign. Now, if you have got a constant is just a number without an x or a t or any letter with it, then what you do is you introduce that x to it, so it becomes 4x. So any number becomes 4x, and don't forget your plus c. Okay, this wee bit's not in your notes, but I'm just going to do it for practice. So if you're asked to do 3x to the power of 8 plus 5, and you want to do the x's dx. So stick to the same rules. 3, carry it down, just ignore anything else there, it's just a number. Add 1 onto the power, so that 8 becomes 9. Divide by your new power, so we're dividing by 9. Then I've got this 5, so this 5 becomes 5x, and I've got to put in plus c. Okay. Second one, if I've got the integral of x to the power of -4 plus 3x to the power of 2 plus 5, and I want to do the x's. So I increase the power by 1, so -4 increased by 1 becomes -3. Always be careful with your negative signs. Divide by the new power becomes -3. Then I've got a plus sign, the 3 just gets written down. Add 1 onto the power, becomes x to the power of 3, divide by your new power, divide by 3, and when you've got a number on its own, it becomes 5x. And don't forget your plus c. Now, that one there can be tidied up. That could be -1/3 x to the power of -3, and those two 3's cancel each other out, so it's plus x cubed plus 5x's plus c. You've got plenty of practice doing that when you're going through the course of the examples. Okay, back to the notes. So we've got to do the integral for part D. It's the integral of 3 divided by g to the power of 4, and we've got dg, so we want to do the g's. Right, there's a problem here. The letter is in the denominator. Can't have that. So you think back to your indices. To bring that up to the top, we change the power, so that becomes the integral of 3g to the -4. All letters must be in the top before we can take the integral. So we've now prepared that, we're ready to go. Drop the integral sign, that 3, just write it down as normal. Add 1 onto the power, so it becomes g to the -3, divide by your new power, divide by -3, and add in your plus c. The only thing left to do is to tidy that up a bit. 3's cancel. Negative signs must come up to the top, so that becomes minus g to the -3 plus c. Okay, next one, we've got roots and powers. So we've got the integral of 6 to the 5th root of p all to the power of 3. That's got to be changed into a power of x. 6 stays where it is, and it's p to the power of 3. But remember, roots are underneath the ground, underneath the fraction. That's the 5th root, so that becomes 3/5. And we're going to do the p's, the p. I should have written that in there as well. Okay, once I get to that stage, that's easy. Just pull down the 6. It's just multiplied by that. There's no adding sign in there, so it just stays. We're going to add 1 on to the power. So I'm going to add 1 on to the power. 1 is the same as 5/5. So add 5 onto that, gives me 8/5. Divide by 8/5, and don't forget plus c. Now this whole thing here looks a total mess. So what we're going to do is we're going to get rid of this thing from the bottom. So remember when you did nat 5 to divide by a fraction, you flip it upside down and multiply. So you do exactly the same here. So I'll write it in a different colour. I'm flipping that fraction and I'm putting in a wee dot, but that stands for multiplying. So flip your fraction upside down as 5/8. P to the power of 8/5 stays as it is, and plus c stays as it is. So we want to tidy that up. I can see that 2 divides into 6. So 2 divides into 6 and it goes 3 times. 2 divides into 8 and it goes 4 times. Nothing else will cancel. So 3 5s are 15/4, and it becomes p to the power of 8/5 plus c. So now we've got another one, and this is taking you to another stage where you've got a string at the top and it's divided by something. Just like differentiation, you cannot do that. It must all be split up. So the key for that one is to split. So we're going to split that up. So we end up with 4y over y to the 2/3. Then we've got minus 3 over y to the 2/3. And we're going to do the y's dy. So we've got to get this all sorted. I've not taken an integral, so I keep the integral sign in, so that stays until I start adding on 1 to the power and dividing with the new power. But this has got to be prepared. So we've got to bring in our indices from last year. So when I'm dividing indices, I subtract the powers. So for that one wee bit there, I'm really doing 1 take away 2/3. What version of 1 am I using? I'm using 3/3. So 3/3 take away 2/3 gives me 1/3. So the 4 stays where it is, that 4, just scroll it down. But the new power becomes y to the power of 1/3. Now we want to then do the next one. There are no y terms at the top there. So since there's no y terms at the top, I can just write down -3, and I bring that up to the top. I'm going to bring it up to the top. I change the sign, so it becomes y to the -2/3, and I'm going to do the y's for the integration. So now I can go through my rules for integration, add 1 onto the power, divide by the new power. So the 4 stays where it is, leave it. Then we've got y, we want to add 1 onto the power. So 1/3 plus 1, 1 is 3/3, so I've now got 3/3 plus 1/3 is 4/3. And I want to divide by the new power, so I'm dividing by 4/3. There's that messy fraction again, but we'll sort it in a minute. Then I've got a -3. I want to add 1 onto the power. So 1 is 3/3, so -2/3 plus 3/3 gives me 1/3. So it's y to the power of 1/3. And don't forget your plus c. Okay, don't like the look of this. So remember we said we flip that fraction upside down and we multiply. So that becomes, that 4 stays. That becomes, and a wee dot for multiplying, that becomes 3/4. That's me flip to fraction. Y to the 4/3 is the same. And this bit was okay, y to the 1/3, and we've got our plus c. Now, when I simplify this fraction, 4 into 4 goes once, 4 into 4 goes once, they basically cancel each other out, and when I cancel them out, I'm left with 3, y to the power of 4/3 minus 3y to the 1/3 plus c. Okay, next part of your notes, next part of the notes are the definite integral. It's just the same. Definite integral just means that when you've got your integration sign, you've got some numbers written down here as well. So what you do is you do your integral as normal, add 1 onto the power, divide by your new power. But once you've got the answer to that, then you sub in that number every time you see an x, and then you sub in that number every time you see an x, and you take both of them away. And basically that's what that whole thing means, okay? So when you do it in practice, when you see it in practice, you don't need to worry about all of this notation. As long as you remember, you do your integral, you sub in the top number, and then you sub in the bottom number, and you take them away. So the easiest way to see this done is actually by example. So this one here, we've got the integral of -1 to 3 of 2x minus 1, and we're doing the x's. So what we do is, this is a notation. We take our integral and we change it into square brackets, like that. So the integral of 2x, now remember 2x means 2x to the power of 1. We're always increasing the power of x. So that becomes 2x, add 1 onto the power, which is 2, divide by your new power, which is also 2. And then when we've got a number, we just introduce the x, so it's -1 mod of x. I don't need the 1 there, but I've just put it in. So now what we're going to do is, we're going to tidy that up a wee bit, because I don't like this thing here. I've got a 2 and a 2, so they cancel each other out. And I don't really need that -1x. So what I'm now doing is, I am doing substitutions for x squared minus x. And the limits, those numbers are called the limits. The limits are 3 and -1. So you make 2 brackets, and you're going to take away the values. So 2 brackets with a minus sign between them. We're going to sub in 3. So we'll get 3 to the power of 2 minus 3. So I've substituted 3 into that. Then I'm going to take away, and I'm going to substitute -1 into that. So -1 all squared, and I've put that in a wee bracket. -1 all goes into a bracket when you've got a negative number, so that you can square it. Then I've got minus, and then x is -1. So a lot of brackets in that one. Okay, once we've done this, it should be okay. So 3 3s are 9. So 9 minus 3 is that first bracket. Then I've got to take away -1 times -1 is +1. 2 minuses make a plus. The second bracket is that. Tidy it up. 9 take away 3 gives us 6. Then I've got minus 1 plus 1 is 2. So 6 take away 2 is 4. So the answer to that definite integral is 4. So to recap, what we do is we take our integral as normal, we change it from the integration sign into square brackets, and we pull the limits across to the right hand side. So I've taken the integral, so that's why the integral sign's going. So tidy it up. Once it's all tidied up, I had that, which looks a lot better. I substitute 3 into that, I substitute -1 into that, and I take both answers away. And that is called your definite integral. Okay, 2 examples here in the next part of your notes, and it's the integral from 0 to 2 of p plus 1 times p minus 1, and we've got to do the p's. So before I even look at that, that's not prepared. So we've got to multiply that bracket out. So p plus 1 times p minus 1, we'll do it the long way. So we take the first term in that bracket and multiply it by the second bracket, and then we move on to the second term and we multiply it again by the second bracket. When I do all of that, I get p squared minus p plus 1p, and that's going to be -1. So that gives us p squared, those two cancel, -1. Now, if you're tuned back into last year, you'd notice that that was a difference of 2 squares, so it's p squared -1. And later on, when you're going through the course and you're doing past paper questions, you'll be expected to be able to see things like that. But it doesn't matter, you can always work them out. So I've now prepared that. So this question now becomes the integral from 0 to 2 of p squared -1 dp. We're doing the p's. So rules just the same. Add on 1 to the power. I'm going to change the square brackets. So that becomes p to the power of 3. Divide by your new power, which is 3. When you've got just a number on its own, introduce the letter. So it's -1 times p. Pull your limits over to the right hand side, so your 2 and 0 go in there. Now we're going to substitute in. There's not much tidying up to be done in that, so I'm just going to leave it. So we're going to sub in 2, so that becomes 2 to the power of 3 divided by 3 minus 1 lot of p, which is -2, so that's my first bracket. Then I'm going to take away the second substitution, substitute in 0, that becomes 0 to the power of 3 divided by 3 -0, work it out. We've got 2 to the power of 3, 2 2s are 4, 4 2s are 8, which is 8 over 3, and I want to take away 2. Now, I'm taking away that 0 and that 0, so I'm taking away 0, that's all 0. Now, we want to tidy this up a bit, so I'm going to change these fractions. You probably will have a calculator to do this, but we should be able to work without a calculator for easier fractions. So that's 2 over 1. I want to change this fraction to thirds. So I've multiplied the bottom number by 3 and multiplied the top number by 3. 3 2s are 6. So that makes that dead easy. I've got 8 thirds, and I want to take away 6 thirds. So I'm left with 2 thirds. Okay, next example in your notes. It's the integral from 1 to the square root of 3 of x squared minus 2x dx. Don't worry about root signs. We'll work them out when we get to substitution. So we want the integral basically of x squared minus 2x's, and we're going to do the x's. They're sums and differences, which means it's something with either something added or taken away in a string. So that's okay, it's prepared. So we want to do the integral. I'll just remind myself of the limits. The limits are there. Forget them just now, change to a square bracket and do your increase the power by 1, divide by your new power. So one other wee thing, we've got x there, which really is x to the power of 1. So we're going to add 1 onto the power, becomes x to the power of 3, divide by your new power, divide by 3. Then I've got -2, add 1 onto the power, so it becomes x to the power of 2, all divided by 2. And close that bracket, pull your limits across, so root 3 and 1. So we'll tidy up what we can, and I can see that a 2 cancels there and a 2 cancels there. So basically that just becomes, I'll rewrite it, although you wouldn't always have to rewrite this. It's x to the power of 3 divided by 3 minus x squared, and we're going to do our substitutions for root 3, and we're going to do our substitutions for 1. Right, so we're going to stick root 3 into this first of all, and then we're going to substitute in 1, and then we'll take both answers away. So x to the power of 3, so that means I've got root 3 all to the power of 3 divided by 3. So that's the straightforward substitution in there. Then I want to take away x squared, so it's root 3 all squared. Then I want to substitute in 1, so it's 1 to the power of 3, which will just be 1. But write it in full when you're doing any question, so that there is no way that any marks can be taken off you for sloppy working. And then x squared becomes 1 squared, like that. So we'll tidy this up a bit. So I would say I would let you use a calculator for that. So root 3 times root 3 times root 3, that turns out to be 3 root 3. You can do that in your calculator to the power of 3. But it's also divided by 3, so we'll write that in. Root 3 times root 3 becomes 3. Okay, that's all tidied. And then over here, we've got 1 to the power of 3, which is 1, so that's 1/3. And I want to take away 1. Okay, we want to tidy it. Those 3's cancel. So I've got root 3 minus 3. So I'll leave it like that because I can't do anything with that unless I use decimals and I don't want to. Then I'm going to multiply this all by -1 because that's what it means. So it's minus 1/3, minus, and minus make a +1. So bits of that we can tidy up are going to be, we've got minus 3 plus 1 is -2. -2 minus 1/3 is -2 and 1/3. But I've also got this root 3 sitting in there. So that's it, without any estimates, without any rounding. Now, you can put that into your calculator and get that as a decimal if you think that is better. Okay, we've got the next one. This one is your integration, but it's going back to front. So they're telling me the answer to this, and they want me to work back and find the value of g, and that's g up there. It's not copied very well. So the question is, we've got the integral from -2 to g, and we've got 6x plus 5. We want to do the x's, but they've told me the answer to this is 6. And I'm going to work backwards to work out what this is. Rules don't change, they stay the same. Maths rules always stay the same, they don't change. So once you've learned your basic rules, you apply them to the question. So we're going to work out the integral of 6x plus 5. Now remember that's 6x to the power of 1. So we've got 6 pulled down, add 1 onto the power, becomes x squared, divide by your new power, divide by 2. When I've got a number on its own, it becomes 5x. Now, you don't put in a plus c when you've got a definite integral, and I should have said that earlier, because at the end you've got one bracket, take away the other bracket, and the c's would just cancel each other out, so you don't need it. So our limits are -2 and this thing g, which I'm going to have to work out, but I know the answer to it is 6. So what did we do when we had limits? We substitute in g and we substitute in 2. But before I do that, I'm going to tidy this up a bit. 2 into 2 goes once, 2 into 6 goes 3 times. So that, in fact, when it's tidied up, it becomes 3x squared plus 5x. And I want to substitute in g, and I want to substitute in -2. I know the answer is going to be 6, but I'm not too worried about that just now. So we'll do our substitution first. So that is 2 brackets, sub in g, then sub in -2, and I'm going to put a wee 6 in there because I've just pulled that down. So when we put g in there, it becomes 3g squared. 5x becomes 5g. This one here, I can put a number in. So that becomes 3 times -2 all squared plus 5 times -2. So we'll tidy it all up. Can't really do anything with that. So it's 3g squared plus 5g. And I want to take away, I can tidy this whole bracket up. -2 squared is 4. 3 4s are 12. 5 times -2 is -10. That wee 6 is still sitting there, I've not forgotten about it. And I'm going to tidy this whole thing up. So I've got 3g squared plus 5g. 12 take away 10 is 2, so that's minus 2, and it's equal to 6. Now I want to go back and work out what g is. So we're thinking about when we've got a quadratic, it's got to always be equal to 0. So we've got a 6 over there, we'll take 6 away from both sides, and then we're going to factorise. So I end up with 3g squared plus 5g, and that would be negative 2 take away another 6 is negative 8, and that's equal to 0. So we recap and factorising. We multiply that by that, gives us 3 8s are 24, so it's negative 24. Factors of 24 are 1 and 24, be logical, 2 and 12. 3 8s are 24, 4 6s are 24, and 5 doesn't divide into it, 6 does, but we'll be repeating 6 and 4, so we've got our factors sitting there. Now, what does it mean when it's negative? It means that one of these is positive and one is minus. So if we make the first one all positive, and we make the last one negative 1, I can have all of those again, but round the other way. So it could be negative 1 and plus 24. It could be negative 2 and plus 12. It could be negative 3 and plus 8. It could be negative 4 and plus 6. So I'm looking for one of those pairs that gives me positive 5. So the pair out of all of those ones that give me positive 5 is that pair there. So we'll now sub that in. So we've got 3g squared stays the same. That middle term is now going to be split with negative 3 and plus 8. So negative 3g and plus 8g. And then pull that negative 8 down. And this is helping me factorise it. Cut it right down the middle. Take out your highest common factor. In this case it's 3g. I'm going to pull that out. I'm left with g minus 1. And here we've got 8 as our highest common factor. Pull it out and I'm left with g minus 1. I now have to form my two brackets. So first bracket comes from 3g plus 8. So 3g add on 8. Second bracket is the repeated one, g minus 1, and that's all equal to 0. So now we're getting towards solving for g. So either 3g add on 8 equals 0, or g minus 1 equals 0. That would give me take 8 away from both sides and divide by 3. So g is equal to minus 8 over 3, or g is equal to 1. Now at this stage, we're going to go back and see if they put any conditions for g, because we've got two answers here. So back right up to the top of the question. And what does it tell me about g? It says find the value of g such that that whole integral is 6. So there's no conditions on it. So we've got two answers there. So either g is equal to negative 8 over 3, or g is equal to 1. Okay, so for that one, it gives us two values of g. Right, your notes now go into areas under a curve and the areas in relation to integration. So I'm going to do that as a separate video so the videos are not too long. So that's the first half of your notes all completed for integration.